Morning. It is currently Friday, 10th of April. It is a work day, but nobody at my job is emailing me back. So I'm taking that as a sign to work on my project for like a second. I was playing around with it this morning. This is the next day from the last video, and just playing with what I discovered about energy and etc. And I noticed something that I didn't notice last time that I think solves a problem that I had in the last video. So I'm going to show that to you. All right, so I was continuing today to play with the acetylcholine function, and I had some other thoughts. I had some other thoughts. So I was thinking maybe because I remembered seeing this -6 here actually in the energy. And what we learned last time is that this energy is, I think, indicative. I need to learn it again because I just learned it, of whether my model is actually staying flat or whether it's going in like a it's like flattening, or what's the word? Actually remembering what it's meant to remember. This is what's actually interesting is I was saying like I expected that if I put the acetylcholine at a more medium point, that what I would see is some of the memories not actually there being some differences in how parts of the memory are remembered, and like a halfway point of failure, because I noticed that at a certain point, basically the system was just, okay, now I really truly can't remember anything. But what I noticed is that I was looking at this my output a little bit wrong. And I think that actually I'm gonna double check this, but I think that each of these lines here is one line in my matrix, the original matrix. And I think that's right because I see that each of these close stored patterns are different. And so what I saw actually this time around, because before it was giving me a bit of a different output, but I had to troubleshoot the output, is that actually it seems like because the energy is low here, that means that this line, I'm going to confirm, but it's not that these patterns are getting recalled wrong, but that one line, like one pattern seems to be getting recalled differently. So let me confirm. You see, so here, this line is getting recalled fully. Okay, so this part is actually getting 100% recovered. This part is getting, or no, this part, yeah, 100, it is getting recovered, the original memory. So you can see in the first few, so -1, 1, -1, -1, and here -1, 1, -1, -1. So that means it is remembering the stored pattern. This one down here is also remembering the stored pattern. So it's like, okay, my memory's right. In this one, it's actually not able to remember. So it actually was successful. I'm like, wow, it's actually coming together. So you see that what happened wasn't that one line, like, oh, the numbers were wrong, which is actually a good thing. It's that it wasn't able to remember the complete memory. So, oh my gosh. So it's actually like just what I said. So it's like, okay, I can remember bits and pieces, but I can't remember the whole thing. So it is actually accurate versus like, okay, I remembered it incorrectly. It's like I just can't remember a piece of it. So that's actually very relevant to trauma and fragmentation. So that's something that I'm probably going to explore as well. That this one kind of had a fragmented recall where it was actually only able to remember a very little, like it was remembering parts of it, but the system was getting that flat effect where it's like here it was not remembering the full pattern, but it was remembering a lot of it. And what it did remember was 100% accurate, but not the other pieces it just couldn't remember at all. So like let's go down now. Now I'm getting really hyped up, and like every single thing that I'm doing is like, well, it's like kind of important. See, so at this point, at around 0.6, it's still remembering like everything, the memory is coming out fine. When you get to 0.7, that's where it's like okay, the memory is coming up, but it's coming up fragmented, where it's like, okay, I got most of it, but this is like a no. And that makes sense because at 0.5 or so, that you're still within the realm of like normal acetylcholine or whatever. Like it's, you need acetylcholine. It's not a trauma. It's not inherently trauma. You see, it's getting more fragmented as it goes along. So this one, it was like, okay, this one it couldn't recall anything. This one also couldn't recall anything, but this one, let's see, -1, 1, -1. It still couldn't recall anything actually. but the energy was still like a little bit up. So at around 0.8, yeah, it's like it's not remembering anything anymore, but there is one point where it was able to recover like a fragment of the memory. Or no, it was able to recover most of the memory minus a fragment. And then at this point, you're truly in like, there's just nothing going on here. Like you really can't remember a thing. Yeah. Yeah. So we are getting memory like almost like a midway point of amnesia at around 0.7 where it's really high, where it's like, okay, I can recall a fragment. I just can't recover everything about it. And I'd have to test this again. Like I have to do this like essentially like 100 times and see what goes on at each point. But this is really cool. Like there actually is like a fragmentation going on here, which is really interesting. So yeah, success. Oh my gosh, I feel like now I'm on like a success like snowball where it's like okay, every single little piece is like it's actually bringing up more positivity than expected, and this actually works really well. And this is something cool to mention. If I see it, the pattern, that same pattern across the board, will be really cool. Really hyped up about that. I'm not gonna get started working yet on this like more, but I think what I am gonna do is I think I'm the next things I want to do are maybe a little bit more troubleshooting. I don't know actually. I have no idea where to go next with this. I don't think I actually have anything left to troubleshoot now. Like I think everything is fine. These are coming up fine. Each of these lines is a line in my pattern. That's 3 lines. I had one thing that I was thinking about doing, which is switching this to sparse coding just because I've read that that's more biologically realistic. But I might mess around with that and see what I think because the only downside is that sometimes there's just not enough difference for you to really get like a clear sense of the difference. Where how sparse coding works is it'll be mostly zeros. Instead of -1 and 1, it's like mostly zeros with like 1, 1, 1, 1. And it's like very little, like it's like a very minute difference. So the only downside with that is like I don't get the same obvious results, and maybe I just don't need that anyways. I just thought I'd keep it biologically realistic or whatever, but maybe I don't need to. I don't know. I don't know what to do actually next, but I think maybe I'll do all this without actually running it like 100 times. What I'm probably gonna do next then is maybe get to work on pattern separation. So let's rename this. This is ours with only acetylcholine. I'm gonna make a copy of this one. We're going to duplicate it. And then the next thing I'm going to do is pattern separation. I need to do reading for that again because it's been a minute since I read about pattern separation. And I kind of want to get more info before I jump in. And we'll see if we can do that next. But I'm really hyped because it's actually working now, which is crazy. After this, when I have results, and I think I'm closer to actually writing my results section than I feel like I am because every day it's like, okay, this is really shifting. And I'm starting to feel really good about my code. Like, it's really well, like, there's nothing that I need to fix. It's actually working now. Like, there's no messiness or issues with it. Um, Basically, I think I'm closer to results than I think. And then once I have results, I can, I feel like actually writing the results section isn't going to be so tough. It's just getting like making the graphics and stuff and running those calculations, which are going to be done with a line of code that I'm going to include. So I don't think I'm actually going to be doing too much math. It's really just going to be writing a good line of code that's doing the math for me, thank God. But I think that I am closer than I think. And then the results won't take that long. And actually, I already have it pretty much like it's very. I'm going to show my final, like my document that I have right now. And I've got so much already written. And it's going to be, I already even wrote stuff for the conclusion that I wanted to explore. But if anything isn't really that reflected, I'll just delete that. But just the things that I was already thinking about in terms of like, how do I conclude this? What do I think I'm going to be able to say from this? I just went ahead and wrote it because I just didn't like it was just like on my mind. So I just wanted to get it offloaded so I didn't have to think about it anymore. So it's all in my paper now. The abstract is very bad. Like the abstract isn't actually written. I just copy pasted it from something else that like a rough draft. So I need to write. I need to figure out a title. I need to write my abstract. Um, this is already like kind of separated out. These I don't think these titles are gonna stay. I think but they were just for me to know what I was writing about in each section. Like I kind of outlined within my own paper. So you can see I already have a lot of things, and then I need to kind of just edit through and make sure that everything is like my own words, because I did copy paste in some lines that I just found like important, or just like don't forget to put this in. And then we have so hippocampal sharpwave ripples as a basis of episodic memory. Be talking about that. The amygdala and neuromodulators work together to facilitate arousal. And this is where I'm probably going to talk about some things that won't necessarily, I don't know where to put them, but there's things that won't necessarily be shown in my model per se, but that give surrounding kind of information about how this works, about salience, about the medial septum as well, and how it creates these theta waves. I need to think, what do I actually need to put in there, and how is that gonna, I don't know, it's like part of writing is also cutting down. And I think I'm gonna cut down probably by the end, because I actually have a lot to say. So these are all like copy pasted in as well. So that's why I highlighted them. I think mostly. So a lot of it you see is already kind of like ready for me to go. And then neuromodulators suppress the production of hippocampal sharpwave ripples. This is gonna get rewritten like a bit. And then, yeah, and then here we're gonna have and relevance. Here, my method. These are the ones that I know, like, I don't think that unless I change something about the weights for my pattern separation, I don't know if that's actually really that accurate. And then maybe, who knows, maybe I'll do an inescapable stress one round of like a little bit more inescapable stressy. I have no idea. And that would probably change something here, but this is already good to go. This is just the most simple and basic of rules. Asynchronous update rule. I don't think I even ended up actually putting this in. So I might see, like, do I want that? It probably doesn't matter anyways, but it's fine. Like, if it works, it works. But maybe just to be more like precise. And then, yeah, my experiments are going to get changed up based on what I'm doing now. Results, we're going to throw the results in. And then you see, I already have a lot for the discussion that I was already thinking about talking about. And if it's shown in my paper, great, I'll keep it. If not, then whatever, I'll just toss it. And then, yeah, my citations are not complete yet, but yeah, so it's already 17 pages long. So I feel like I'm in a pretty good spot, but it's just gonna be about shaping everything based on my results. And yeah, it's really getting close to done now, which is really cool. And I'm not gonna lie, I'm gonna need some figuring out to know how to write these rules and equations and stuff into my paper. This one's obviously pretty easy, but I don't know how to write, like, I don't know, like this stuff. I don't know. So that'll probably be, I think the results section is going to be challenging to write for me at my level, but it's not going to be impossible. Like, obviously, I'm going to be able to do it. So, yeah, it's crazy. Like, it's really getting somewhere now. This needs to be gone, though. Okay, I actually just changed something up as well. That was like a troubleshooting thing. Right. I did have one fix, which is that my pattern size was too small. It had the old one in there for some reason, so it did change the size of the, like, the amount of the energy, but it didn't really change the impact. Actually, it did change the impact quite a bit. So you can see that, you can actually start to see the effect that I was talking about at a weight much less acetylcholine, which isn't a bad thing. I think it's actually a good thing. So you can see that at around 0.3 it starts to get like fragmented already. And then at 0.4 it's already starting to repress, like it's already making it like so it can't. So all that basically changes that you're already starting to see the impact that I was talking about at less acetylcholine and just like more. So, which is actually a good thing, because that's probably more realistic. So like you're already seeing that it can't recall the full memory at around 0.3. Like, this is right, this is right, but this it can't remember, which makes sense because you're supposed to be in a state of arousal. At around 0.5, it's like like it's less recall. So only a little bit can be recalled, which is only one pattern. And then let's see if it's at the same point that it completely flatlines. It actually starts to flatline at around 0.6. So it basically is the same result, but the energy amount is smaller. That was like one mistake, is the pattern size was like way too small by accident, because it just didn't copy out the old pattern size. I think I just I don't know why that happened, but yeah, so you actually start to see the effect at around 0.6 this time, but you also see more variability as well, which is really cool. So you can see more variability in like, okay, here it's like I can only remember like the tiniest of bits right now versus like, okay, I can remember mostly everything. So it actually strengthened my point because this is more accurate. And then once you get way up to these amounts, it's like nothing, like truly nothing, and the energy is really low. And then you get to 1 and it's just nothing. So again, it just made it like a little bit more sensitive, which is good. So yeah, I guess I'm still like, I just want to go back as well, like 0.5. This is really cool now. Like you can see that it's like, okay, it's not recalling anything except for like a very little bit. It's remembering this bit, but it's not remembering the other patterns at all, which is so, oh my gosh. It's like that's even better now because it's more subtle, and you see more variability in terms of like how much can be recalled at different points versus like, okay, it's like everything is perfect and then flat lines at a point was like kind of like why. So yay. Okay, yeah, I guess I'm gonna go for a walk, and tonight I'm gonna try to start working on pattern separation because this one is like it's pretty strong now, which is cool. Hello, it is just later in the day. I have been so sick today. I've genuinely been in bed all day long, just in bed, like just feeling so sick. I don't know if it's because I ate gluten, because I have a gluten intolerance, but I always convince myself that I'm like, I gaslight myself, and I'm like, you're making it up. Like, no, you don't. And I'm like, it's all in your head. It's psychological. And then I'm like, okay, like I'll eat some gluten, and then I eat it and I feel so sick, and then the loop just continues. So I did eat like a bunch of gluten the other day, convincing myself that the intolerance is gone, and it wasn't. So yeah, that's what I've been doing in bed all day, is just lying around. I've had no appetite. I had half a pho and a gluten-free and vegan cheesecake that I got from Uber Eats, and hours have passed and I've just been like, I just can't do it. But the show must go on. Does anybody else convince themselves that their freaking gluten intolerance is fake? I'm always like, this is psychosomatic, but then like it just messes me up still. So I'm like, okay, I guess not, unfortunately, because I love bread and stuff. But okay, so this is where we are. This is like the duplicated one. Essentially, I was refreshing on pattern separation and like how it works. I had a feeling, okay, in my last video, I said sparse coding, and I was the terminology or the accurate terminology, and it is. So it promotes sparse coding. I'm going to try to pull up my sparsely coded Hopfield network that I made at one point. This is the one that I made that was sparsely coded. So what you can see is that instead of a bunch of numbers, it's just zeros and ones, and they're very, very far apart compared to, and I actually made it even more far apart than before, but they're very far apart compared to like my other one, where it's like one is lit up and it's like a bunch of them aren't lit up. I was doing that reading and I was thinking that I could basically implement a thing in the actual patterns and it would change up this part here somehow, where basically if the acetylcholine is up, the initial stored pattern is like sparser. That was my initial thought. It could just be like that might, I don't know. I'm gonna see if that's like an appropriate thing, but patterns just get sparser the higher it is. And then if acetylcholine is low, it could just be like really dense. I need to figure out how to like super implement that, but I think that's just pretty much all that it needs to be. But I might be wrong. I think that's it. Think this is it. looks like my usual spot. I haven't fully like internalized everything yet. I read all this in papers. Like I already read like many papers about this along the way because I read a lot about acetylcholine, but I just wanted to refresh because I haven't interacted with those texts in like a minute. So yeah, you park your car in a slightly different spot every day. Each memory is very similar. That's one thing I could do. What it basically does is that when acetylcholine is up, it makes it so that you know that the memory that you have is that you just made is very distinct from other memories that you have stored. What's interesting is like there's different places that could kind of mess up. I don't know. Because this is the pattern that you have stored is this closest stored. So that's the one that goes in at the top. Recovered pattern. Let me think some more. Oh my God, I'm so sick today, but I'm just trying to feel better. This is the thing that's a bit messy is that the new information coming in, this input from the outside world would actually be the noisy pattern. It would, well, you know what? There's like a few different problems here because it would basically be boosting the signals coming from the noisy pattern. But the point of a Hopfield network is essentially to learn the pattern that's like stored. Oh, well, I guess that actually makes so much sense because that's the problem, right? It's encoding. So it's probably going to have to mess with the noisy pattern. Like it makes you better able to recall what? Better able to encode the noisy pattern versus like not mixing it up with the new one. So it actually kind of does the exact same thing. Let's look back at the sparse coding thing. I think that's going to be key still, maybe. You know what would basically be happening is that if acetylcholine is going up, oh my goodness, my cat. I feel bad because I've literally been in bed all day and she's so needy and she relies on me for like she can't entertain her. Well, she can sometimes, but she's probably like, why are you boring me? Like you've done nothing and not entertain me at all. It's like, sorry. Anyways, as acetylcholine is going up, it would actually be interfering with the noisy pattern, which is super interesting. So it would be making the noisy pattern more like sparser, but that also like, I don't know, there's like inner mechanisms of the Hopfield network as well that I'm like, wait, I don't want to mess that up though. The thing is that if the pattern separation is low, I think you're mixing it up with memories that you already have. Like everything is exactly the same. So this is what's crazy is that if the acetylcholine is low, what it should do in theory is like it should make the noisy pattern dense and it should make it dense and similar to the stored pattern. So I don't, again, it's like I have to let it sit. I don't know how I'm going to implement all this yet. It's probably simple, but it'll hit me. So this will be pretty interesting because it's actually going to be, I think, interfering with the literal patterns, which kind of the only problem is that it's like, well, you don't want to mess up the memory. I don't want it to be like, the thing with these is that it's kind of like I'm going to show a picture of Hopfield networks with images. See, this is what it's basically doing is that you get this picture here, which is like what you learn. This is almost like I learned like it was saying the ChatGPT example was like I learned my parking spot where it's like wait, actually let me use it because it's kind of good. If you park it in a different spot, this is kind of like if you learn like your McDonald's order and then you're looking at like McDonald's menu or something, and then you're like, okay, I remember my order now. Because I don't know if it's kind of similar to that. I don't know if I explained that the best, but I want to find this is the one where it's like it something was wrong with the network. I don't know what, because I never read whatever this link is. And obviously the recalled picture was like actually genuinely distorted. I guess that probably is I don't actually know. I don't know if I want this effect per se. What should happen in theory is that it should just be a bunch of jumbled noise that looks a bit like this and like this. Like this looks like a bunch of different messes. I don't know. I'm just too tired for this, but that was the start. And I think that it will get more sparsely coded as the acetylcholine goes up, which will make it there's complications I need to think about because I don't think I'm fully comprehending the subject matter yet, but it'll be something like that. And I'll probably just get Claude Code to write a good little like randomness seed thing that's gonna implement pattern separation. I'm gonna stop for a bit now and just let that soak and see if I get myself something to eat. Okay, a lot of moaning and groaning later. Here's my next thoughts. Okay, I think it's gonna miss the mark a bit, but maybe it's heading in the right direction. So we're gonna take one line of the pattern. We're gonna put it in my notes app, okay? Then we're gonna take the noisy pattern version. Okay. So the way that my thing works now, wait, am I insane or is the line longer? Let's try that again. If you can tell, I have a feature that's supposed to randomly generate this number, and then it makes a randomly generated noisy pattern with 20% noise. So it's like a little bit noisier than this. You see, there's a lot of overlap in the numbers. I don't know. This is one initial thought, but it could be like the normal memory is like this. And then if the memory is like, as acetylcholine goes up, maybe you can make it like if it's low, it could be like there's overlap between this and that. Wait. Because if acetylcholine is up, you want the noisy pattern to be like distinctly different. No? I don't know. And I was gonna say maybe like if it's high, it could be like this. And then here it's like 0, 1, 0, 0, 0, 0. So it's sparsely coded and has like no overlap at all. But then that just messes things up by a lot. I actually don't know. So like here the noisy pattern is very similar and here the noisy pattern is very different. We'll come back to this. Morning, it's the next day. I haven't even gotten out of bed, which is why my bangs are crazy. I've been spending the last maybe hour and a half just troubleshooting my new code because I started to make one that was so far just a normal Hotfield network, like nothing special except for like some of the fixes that Cloud Code made on my other one. But I want it to be sparsely coded. That's it. That's the only thing. And it's been a struggle. I was gonna stay just like doing it, but I thought it'd be kind of fun to show because I'm switching my Claude model for the first time. So as you can see, it's just supposed to be it's pretty much just the same as the other one, except I took acetylcholine out completely. So it should just be operating like a normal Hotfield network, but with the same size and everything. But so like if it's sparsely coded, for people who may not know, my other one was like negative ones and ones, you can see, but it's actually not as biologically realistic. And the reason I was going to start implementing the sparse coding is because in pattern separation, the higher acetylcholine goes, the more sparsely coded the system gets. So I was like, might as well switch to sparse coding in a normal way so then I can play around with that element. So yeah, so you can see here. So now it's zeros and ones, and they're like a few of them are active, not all of them. But I've been sitting here for the last like hour and a half because I'm having this issue. I had so many different issues over time. First it was fine. Then it started to like things were so off that I was getting like twos. I was getting like negative ones and twos. I was like, that's not right. That shouldn't ever be happening. So it was like it got worse. All I was trying to do was fix the fact that I was getting too many ones in the recovered pattern spot. And I'm still having that issue. I've fixed so many different things and I'm still having that issue like over and over again. And I'm like kind of have just been going in circles. So I thought that I would change the model that I'm using because I was using Claude Sonnet, which is apparently cheaper, but I thought that I would use Claude Opus because apparently it's really good at debugging subtle dynamical systems bugs. So I thought that that would be really good because I feel like I've just been going back and forth and I'm like, obviously something is wrong here. So this is the first thing that I've gotten kind of like information I've gotten from Cloud Opus, I think. So I'm gonna try it. All right. So yeah, it's already starting to get more to the problem. So the recovered pattern may have way more ones than your stored pattern. Your stored patterns have around 5 ones, and recovered patterns have 12 to 14 ones. So apparently the network is falling into a spurious attractor that is denser than any stored memory because the threshold and the slash bias is too weak. I've noticed that this happens so much more with sparse coding. I don't know if it's because it's only zeros and ones, but like it gets blown up with ones super easy. I tried to switch like my old one into sparse coding before, and it was like all ones. It just gets like really blown up with ones, super duper easy. We're gonna also steal this little. I've been collecting the rules that I need for my correct collecting the rules I need for my result section. So, or my method section, and this is one of them probably. So when we see them, we have to copy paste them. Because unfortunately, I don't know how to do these on my own. Wait, let's try it now. Not expecting this to work, but if it does, I'll be really happy. 0, 1, 0. Sparse coding is so annoying. It's very annoying. Why is it so difficult? You see, I've been collecting my rules. We need, what is this one? Sparse Hopfield rule. As you can, I think, see immediately, I don't think that it is fully accurate even still. It's also annoying, and I need to fix this, that it like all of these, it's doing like zeros and ones, and here it's doing like it's not turning it into, I think, an integer, but I might be wrong on that. That might not be the right terminology. You can already see it's still got way more ones. I don't understand what's so hard that like it's just not. All right, so this one, I'm gonna show the places that it's like messed up. This one shouldn't be like this. Okay, as you can see, it improved a lot. Okay, so my system is now a lot better than it was. It had like one, two, three, four more ones than it was meant to. This part has been really irritating. We're gonna try that again. I was saying in another video how like this whole process has been like 1% actually implementing some kind of like neuroscience thing and like 99% just troubleshooting. As you can see, this is like a tiny bit I'm showing you, and I've been doing this now for 2 hours, and we're still having the same problem. Okay, actually, just about a few minutes later, it made one little fix in the bias rule, and it came out mostly fine this time. This one is fine. This one is fine. Only this middle one has issues now. So obviously it's a lot better. Um, and I would say like, there can be a little error, but it's like I don't really want errors because that complicates things. So I'm just gonna ask and see if there's like anything else that can be done to make this like a little bit better, but it's now mostly all the way there. 2 out of 3 of the patterns were able to recall perfectly, but the middle pattern wasn't. But my stomach is really growling now. So I have to eat breakfast. All right, breakfast has been had, and I fixed everything. So on top of the other fixes, so I was having the issue that I was mentioning, which is that two of them were turning out perfect, and one of them was a bit wrong. And it told me that one of the best things to do for that would probably be to increase the number because what it was actually doing is that it was recovering its own pattern, but then also pattern zero. So it was like mixing up different patterns in the middle one. And it told me the best thing, like, it fixed my update rule. And then also, what happened is, yeah, and then also I made it so that this time, instead of 25 neurons, it's 50 neurons. And that worked. So now it's working perfectly fine. It's an eye sort of look at, but it's working fine. So yeah, that's basically what I've done now. So now we have a good base. I'm gonna actually copy this one as well. Because at the end of the day, I'll probably have to make my, oh my gosh. I'll have to make this recurrent I'll probably have to make the recurrent excitation, that thing that I've already done with the acetylcholine, also be sparsely coated if we're going to keep it consistent across the board, especially because I want to mix everything at the end. So this is our copy of it before I go off making more changes. All right, I'm going to be done for right now because now I have to do some thinking, and there's one of these patterns is going to be getting more or less sparsely coated, I think, as it's going up. And I'm not quite sure yet because I need to reflect and I need to look back on my research that I did on paper and figure out which of these codes should be, like, which of the patterns should be separating. But I think what will happen is that it will get more sparsely coated or less sparsely coated. Hello, it's later in the day. I just came back from Mauritius wedding shopping. I'm going to a wedding in Mauritius this summer, and I had to get like a sari. I got bangles. I got all of it because Mauritius, if you've never heard of Mauritius, it's a tropical island off the coast of like East Africa, I think. But the culture is very Indian influence as well as other places. And yeah, someone in my life from Mauritius invited me to a wedding. So I had to get like everything. And I'm back. We went to a very Indian neighborhood and I'm back with chicken biryani. And I'm supposed to be watching Prelude to a Kiss, but I just got like a bit inspired and I wanted to talk about what I'm thinking about. So this is an old, by old I mean from a few months ago, document that I made of all the different things I had wanted to be in my model. Um, and sometimes you do work and it just feels like, oh well, it wasn't worth it because like I didn't do this or that, but then it comes in handy. So there's everything that I had learned about pattern separation that I had wanted to include. This is a challenge that I'm having right now. Essentially, what pattern separation does. There's this other piece of the brain called the dentate gyru. This is just pretty interesting, is that it's actually when it's inhibited by acetylcholine, that promotes pattern separation by increasing sparse coding. And basically what that means is that, so it wants to make sure that, like I said earlier in the video, that you have a very distinct like recollection of that memory and it's not mixing it up with a bunch of other memories. My challenge is that that implies a past memory already. The point of this part right here is to learn a memory, and the point of this part here is to recall the memory that you learned. But by this point, there's just only one memory at play throughout the process. What I thought that I could do in theory, so I thought that the place that I should be messing around with is like this part right here with the patterns. Okay, these are just thoughts. This has been kind of a challenging one. What I thought is that I need to see if there's, I don't know how to, I keep figuring out what I'm trying to say and verbalizing it internally, but it's really hard to verbalize it for some reason. I need to have some consistency because I need to make sure that the second part of this, which is going to be my acetylcholine, is working fine. What I thought is that I was actually inspired by earlier when my system was doing part, like, basically what was happening is that it was learning part of like, instead of learning the pattern, that like just one pattern, it was learning a bit of one pattern and a bit of another pattern. And I think that's what would happen essentially if acetylcholine was like too low. So it would learn two patterns. So I thought that I could have a second pattern too. I could make a second pattern other than the one that should already be there. And that one's like a very, like a, yeah, like a second pattern. And essentially the point would be that if acetylcholine is up, then the learned pattern is going to be dominating. And if it's like completely down, it's almost like I'm adding a Hopfield network in at like the previous result of a Hopfield network onto my Hopfield network. Like, okay, let's say you learn a second pattern. So if it's up, the learned pattern is dominating. If it's like medium, you get kind of a mixed pattern. Like almost as if one of them was like, this is what happened already just by chance in my Hopfield network. So it's like 0, 1, 0, 0, 1, 0. And then the other one is like 1, 0, 1, 0, 1, 0, 0. Okay. And if the acetylcholine is all the way up, it would be this is going to be dominating. But if it's mixed, then you'll get what I got earlier, which is something like 1, 1, 0, 0, 1, 0, where it starts to pick up pieces of the other pattern. That's what I think should happen. There's already a name for it that I learned earlier because my system was doing this and I was really annoyed. Spurious attractors. This is a classic Hopfield network phenomenon, spurious attractors, also called mixed states. What's happening with pattern 1? So basically what's happening is that the recovered state contains all of pattern 1's neurons plus several pattern 0's neurons. It's settled into a spurious attractor, a stable state that is a blend or superposition of stored patterns. This is a well-known limitation. So I'd basically be saying like, this is what's going to happen if acetylcholine is lower, but it's going to be happening up here, I think, which is kind of complex. So what I'm saying is that acetylcholine would stop us. Acetylcholine would prevent a spurious attractor. That seems right, doesn't it? I think that's how I'm gonna do it. I need to like it soaks throughout the day, you see. So I actually woke up this morning like I felt so sick and weird last night, and then I woke up and it was like it sunk in, and then I went about my day today and it sunk in a little bit more. And I think that spurious attractor issue was actually like my inspiration of like, okay, I think it needs to make accident like a high acetylcholine prevents a spurious attractor from occurring. In the thing is that instead of doing it down here, I needed to do it up here. There's a reason that I know that I think this to be true. I'm just trying to because this part is the encoding phase and this part is the recall phase. So because I'm looking at acetylcholine, I want this to be happening in the encoding phase because this wouldn't necessarily be happening in the recall phase in a brain. It would be happening in the encoding phase. And this part is the encoding phase, so that's why it needs to happen up here. So it just needs to have a second pattern that it can mix up here. So I'm going to figure that out in a bit, and this is going to involve like a bit of Claude code. Right, a while later, and I've just been reading back through this paper called Acetylcholine and the Complex Interdependence of Memory and Attention by Alexandra L. Decker and Catherine Duncan. First of all, I love to see female names in my neuroscience papers. I know it's a little thing, but it just makes me feel happy. But also, I need to read this whole paper like 10 times, to be honest. There's so much to like unpack, I think. But I was going back through it and just asking ChatGPT to explain some stuff for like break it down a little bit so that I could see it just simpler. And so normally this is actually what I'm like, this is close to what I'm saying actually as well. So what acetylcholine does, so normally groups of neurons fire together forming synchronized rhythms. But with high acetylcholine, neurons fire more independently and less in lockstep. This is called decorrelation. And then also, another thing acetylcholine does, it weakens lateral connections, so communication across nearby neurons, and recurrent connections, so feedback loops like CA3 and to CA3 in your model. We already know the recurrent connections part. I've already done that, or like messed with that in my recall phase, I think. There's so much that I can put in here that I'm getting a little bit overwhelmed by the amount of stuff to do. But it's basically the same thing as I'm saying. So neurons fire more independently as acetylcholine goes up. That actually goes back to what I was saying with like, I would think that if acetylcholine was basically up, then you'd be more likely to have the problem that I was having earlier where you get like a lot of ones, like something like this, because it's like if acetylcholine is lower, it's it's making more of them fired together. That's what I was trying to say. So I'm gonna see if I can kind of, so just good information also for how to communicate this what I'm trying to do. So I might actually copy paste this into my method section, like the terminology, so then I have the terminology. So we want to suppress this is all terminology from the paper. This is, I literally said, can you explain this to a section? That's it. So this is all the words from the paper itself. This is all exactly the same stuff essentially. So it reduces horizontal spread. And I think actually my solution was pretty good already. I actually asked ChatGPT like, what do you think? So it corrected me that what I'm talking about isn't pattern separation per se. It's actually has to do with CA3 attractor stability. So it's right, just frame it as acetylcholine modulates attractor interference, not pure pattern separation. So, but I told it like this is what I want to do. So I was like, I could have the real normal pattern the system is meant to learn, and I can have the secondary pattern that is a stand-in for another memory. If acetylcholine is up with a function in my network, it makes the normal pattern dominate. But the lower it gets, the more likely the learned pattern is to become like a spurious state, a blend or superposition of both patterns. Is that sound logic? And it was like, yeah, but it just was like, what you're modeling is about CA3 interference and attractor competition, not then take your, like, that's right, that's true, actually. So it was into it. It was liking it. So I just want to make sure that the way that that gets played out is touching on this stuff too. So basically, so that just helps me to see like what it needs to do. So basically what will be done is that the higher up it goes, or no, the lower it is, I guess the more the neurons can kind of like cause interference and activate each other, causing like more ones, I guess. And the lower it is, I mean, the higher it is, the less, let's see, the higher it is, the more it suppresses lateral connections. So as it's going up, the more it's suppressing lateral connections. So yeah, that's kind of what's going to be happening here. I can't believe I figured this out on my own. That's pretty crazy. I keep being surprised. The thing about that I'm learning about computational neuroscience is that like there's not, I feel like I went in like, what if I have the wrong solution? But there's not really a wrong solution to be had. I don't know, it doesn't seem like there's too much, there's not like a one size fits all approach to how you're supposed to go about answering the problem. It's just about being smart about how you get those elements into your network. It's not like there's like a rule of like that's not how you do it. Is I'm pretty sure. So I feel actually pretty good about my solution, and I think it's gonna be go well. I might honestly stop this video now and edit this and publish it, even though I don't know how long the video will be right now. It might be short, and I didn't conclude it with me actually doing it because I'm really tired. But the reason that I want to put this video up is because I have my side job in the morning, and going to my side job at this point feels so demeaning because what I'm doing is just working as a receptionist at a hostel and like making beds and stuff like that. And it's like, it's not a bad job. I don't think it's a bad thing to do. I really have worked at this side job for almost 3 years now, but it's like it's not matching the level of like, I'm actually doing so much serious work and it feels really annoying. I have like a real job, I have this, all this stuff, I have a master's degree, and it kind of like gives me like this little like annoyance every time I have to wake up on a Sunday morning to go to my side job when I'm doing so much complex stuff, and it's like there I go again to my hostel job. So it's kind of annoying, but it's like I gotta do it just to keep the financial stability. But that's why I'm gonna publish this, so I can be like, I can wake up and be like hyped up that I like completed a segment of this, You get me? Because I hate this job. Also, Prelude to a Kiss, let's end it on this note. Prelude to a Kiss is creepy. It's actually giving me a creepy vibe so bad right now. I had to look up what was going to happen because I was confused, but this movie is so bizarre. First of all, it's so bizarre seeing Meg Ryan in this role because she's like a very like liberal, like artsy girl, and she's just so free spirited. And usually in Meg Ryan, it was after this movie that she got typecast as like this super like type A personality neurotic woman, and she's playing so the opposite of that. So it's really interesting, and it's like kind of hard to like convince myself of the character because I always see her typecast as like this is my first time seeing her as this. And then Alec Baldwin, all I can see him as now, low key, because I hadn't really seen him in many movies, is like the SNL Trump guy. So it's like the SNL Trump guy and this woman in like total opposite energy. And then just the plot is creepy. She switches souls with an old man, and so like the old man is like pretending to be her because he's in her body, but her husband catches on. But it's really creepy like when you think about it too hard because he's like they were on their honeymoon and he was like put a baby in me. And it's like what? I don't know. It just kind of it's giving me like the heebie-jeebies a little bit. It's a really strange movie in my opinion if you think about it too much. And for some reason, what's his name is in it. I was watching this Stanley something. This guy, Stanley Tucci. Is that how you say his name? I was watching him the other day in his like new movie about his TV show where he just goes to Italy and like tries Italian food. I don't know. It was just kind of random. Like I just like encountered him again, but in this random movie that I just bought for $1 a pound at the thrift shop. And I was like, what are you doing? I'd never seen him act before. I thought he was just like isn't he like on CNN or am I insane? Wait, I think I'm mixing people up. Wait, I don't think it is him who I think I'm mixing people up so bad. Wait, he was the one in freaking Devil Wears Prada, wasn't he? Wait, I mixed him up with somebody else so bad. Who am I thinking of? Oh my gosh, I feel so bad. I totally mixed him up with someone else. Who am I mixing this person up with? Am I insane? There's like an Anderson Cooper. Why did I mix it? Oh my gosh, they look nothing alike. It might not be Anderson Cooper, but I think I was thinking. No, they do look alike. Oh my gosh, I wasn't insane. I was like, this is the guy from CNN, and it definitely wasn't. Okay. Anyways, that really changed my relationship to this movie, but I think we're gonna be done here because I just need a little bit of like a self-esteem boost before I go to my side job tomorrow, and I'm like customers are like constantly harassing me to do their laundry, and like I'm dealing with like the most random and insane things. Yeah. Anyways, kind of exciting because in the next video you will see me putting all of this into my Hopfield network. So end it on a cliffhanger.